Welcome to This Is My Architecture. I'm Matt from AWS, and today I'm joined by AK from Okta. Thanks for joining.
Thanks for having me, Matt.
So I'm really excited to have you guys here because you're an all-in AWS partner. You're doing everything on AWS, and I know so many customers who use your services. So tell me about what Okta does.
Yes, Okta is a cloud-based identity and access management solution. We provide authentication services, single sign-on to cloud applications, two-factor authentication, and general identity functions too.
That's great. Yeah, so when I think Okta, you think SSO, you think identity, you think MFA. But here on the board, we have these analytics services. So what do these analytics services have to do with what Okta does?
So Okta collects a lot of events, a lot of data around user authentication, user behavior around accessing applications from all over the world. And our customers have pushed us to collect the data and make it available to them so they can analyze it. And it includes dashboard or running reports using that data. We had a database-based architecture using MySQL over the years, but as we have grown, the load on those databases has increased exponentially, and we have seen lag times of 10, 20 minutes before an event shows up for a customer.
Wow, yeah, 10, 20 minutes for events for something like security is
Absolutely
not acceptable. So how much data are we talking about to get that kind of lag time?
So we have thousands of customers with millions of end users, and we are talking about petabytes of data.
Wow, is that petabytes per day?
Yes.
So petabytes of data per day, you need a serious system to be able to handle that kind of a load. And what about other solutions in the market? Are they taking a similar relational database approach?
So our competitors are still using the older model where they have a database and they even publish their latencies, and they're up to 30 minutes, 45 minutes on average.
Wow, okay. So what you've done is built a new architecture to dramatically reduce the sort of time to data that you can get at this information.
Right, and our customers don't only need it for security reasons, but there's also a help desk angle where if somebody is having a hard time getting to log into the system, they have to wait 45 minutes before that log gets updated. It makes it really hard to troubleshoot issues.
Yeah, and customers are demanding these days. It's a real-time world. You have to be able to answer those support calls really quickly.
Absolutely.
Yeah, so tell us about the architecture. I see you have Kinesis up here. How does that connect to sort of the core Okta service?
Sure, so the core Okta service, as you already know, runs on AWS all over the world. And we use Kinesis, so we replaced our MySQL-based backend. We use Kinesis to collect all the events that are happening in an Okta system, including authentication, single sign-on, and we process them here. From here, we pass them along to Apache Storm, primarily for sliding window analytics, so our end-user admins can see the data and drill into certain subset of time-sensitive data.
So that's great. So you have all of these users, all these logins and other events happening. All of those events essentially go into Kinesis streams, and from there you pass that into Apache Storm. I know Apache Storm is really good for sliding window analysis and other type things.
We also do other processing here. So, for example, we strip some privacy data out. For example, we collect city data, geolocation data when you log in. Our European customers think that is PII data, so we strip that out before passing it along to Kinesis Firehose.
Okay, so Apache Storm is not just used for sort of the analysis, it's also used for some data processing and for compliance or other rules that you have to comply with in Europe, et cetera.
That is correct.
That's interesting. So from Apache Storm, that's good for some types of analysis, but then what happens to the data after that?
Sure. So from there, we transfer the data out to Kinesis Firehose. And here we aggregate, we use it as an aggregating service. So we send the data out to Lambda. Here we, again, strip some data out and add some metadata for additional processing. We have functions here where if there are issues with the data, some fields are missing, to alert. So we use SNS for that.
Okay, so if there is an issue with the data, you can alert sort of administrators, or is there any auto remediation happening?
Right, or we can mark that data in the log file so that admins can see that.
Got it. So why are you actually using Kinesis at this phase? What eventually, or Kinesis Firehose specifically?
So we are looking to aggregate this data so that it is available for long-term storage in Redshift, which is our BI system. So in addition to providing all these services to customers, we are also interested in this data and seeing how applications are being accessed.
For your own analytics.
For our own analytics. So for example, from here, we store this data in S3, and then for long-term storage, we move this data into Redshift. So some of the reports that we run are, you must have seen our Business at Work report, where we publish it every year, and it shows you what is the cloud adoption. So industry analysts are using that. So for example, AWS moved from number 8 to number 4 in the last 2 years. All of that happened using the data that we collected.
So a lot of people use Kinesis Firehose not only to push to S3, but also to sort of prepare the data for better parallel loading into Redshift. Are you doing that as well?
Absolutely, we are using Firehose for that as well.
Great. So I really like, so going from Kinesis Stream to Apache Storm, it's nice that you have kind of 2 tiers of data, really. Is that so you can do different types of data analysis?
Right, exactly. So this is, as I said, targeted towards administrators of customers who are interested in security events. This is more for our business analytics, report generation, and drawing long-term insights from this data.
It's actually a really good example of why it's important to not just think of one service for analytics, but to think of different use cases, different users. So very cool. So I like how you have this scalable system that can scale to petabytes and more in the future. What are you thinking in the future? How will you evolve this architecture?
Right, so even from day one when we put this in place, long-term goal was not just give customers an insight into what was happening in their environment, but also use machine learning algorithms and perhaps AI down the road. So we have plans this year next to invest in that and remediate based on what we see in events. So for example, anomaly detection, somebody trying to log in when they're not supposed to log in, those kind of events, rather than just waiting for an admin to find that, proactively alert or maybe even block access based on that.
Yeah, AI, ML, it's all the rage. I like how you're thinking of AI in that context. A lot of people think of sort of image analysis, but you're talking about anomalies, like things that are strange about how users are using the system. There were humans here, but you're going to hopefully replace it with machine learning going forward.
Absolutely.
Very cool. Well, I like how you're thinking for the future, and more generally, the architecture now is interesting. It's nice to see how you've evolved from that sort of large, creaking MySQL database to this much more scalable and flexible architecture. So thanks for sharing it with us today.
Sure thing. Thanks for having me.
And thanks for watching. This is My Architecture.